In this lesson, we'll be studying another type of series. It is called the geometric series. What is a geometric series? It is the sum of the terms of a geometric sequence. There are two kinds of geometric series. The first one is the finite sequence, where the terms are finite. The second one is the infinite sequence, where the terms are infinite. It is usually denoted by a sign called ellipsis. The formula for finding the sum of infinite geometric series is sum of n terms is equal to a sub 1 multiplied to the quantity of 1 minus r, or the common ratio raised to n, or the number of terms, over 1 minus r. The formula for finding the sum of infinite geometric series is sum of infinite terms is equal to a sub 1, or the first term, over 1 minus r, or the common ratio. There are two kinds of infinite geometric series. The first one is the convergent geometric series, and the second one is the divergent geometric series. A geometric series is said to be convergent if sum exists. This happens when the absolute value of r, or the common ratio, is less than 1. A geometric series is said to be divergent if the sum does not exist. This happens when the absolute value of r, or the common ratio, is greater than equal to 1. Let's now proceed with our first example. Find the sum of the first 6 terms of the geometric sequence: negative 6, positive 18, negative 15, and positive 162. Determine the first given value. A1 is the first term given in the problem, so A1 is negative 6. Our common ratio is
negative 3.
We can determine the common by dividing second term with the first term. And the number of terms is 6. After we determine them, we may now use the formula, this problem is finite, like we said earlier, that we can determine the problem if it's finite or infinite by looking at its common ratio. We now substitute the values given. We should follow the PEMDAS rule.
If we simplify negative 3 raised to 6, the answer will be positive 729. If we subtract 1 to 729, the answer will be negative 728. We now subtract 1 and negative 3, the answer will be positive 4. The sum of the given problem is 1092.
Sample 2 has a different situation. In this situation, where the first term and the last term is given, we will find first the common ratio. We just assume that A3 is the last term. In finding a common ratio, we will use the general formula in getting the quadratic sequence, which is a sub n is equal to a sub 1 multiplied by r raised to n minus 1. Substitute the values given. 36 will serve as the last term. Let us subtract the exponent first. After this, we will divide both sides by 16. So we can cancel 16 beside the r. Next, we will square both sides. 3 over 2 is our common ratio. Now that we got the value of the common ratio, we may now use the finite formula in getting the geometric series. Again, substitute the value. We will always follow the PEMDAS rule.
The sum in this given problem or equation is 211.
For our example number 3, find the sum of 4 plus 4 third plus 4 over 9 plus 4 over 27. It is an infinite geometric series, so we are going to use the formula for geometric series. As we did before, we are going to list down the given first. A1 is equal to 4 and our common ratio is 1/3. Now we will substitute the given values to the formula.
In dividing whole number and fraction, we can multiply them and don't forget the reciprocal. Our final answer is positive 6.
For example 4, this is a kind of situation that we should find the value of a first, or the first term. In finding the first term, we may use the formula in finding the geometric sequence. Once we list down the given value, we may now again substitute the values.
We should always subtract the exponent first. Our first term is positive 9.
Next is, once we found the first term, we now may use the formula in infinite geometric series. First, we always need to list down the given values so we will not be confused. After that, we just simplify, substitute again. So our final answer is 27.
Now is your time to answer this question.
You may pause the video while answering.
The sum of the given problem is 4,372.
Thank you for listening. See you again next meeting.